Dr. Prakash, sir?
Hello.
Yes, sir. I think you can put on your video and you can start, sir. No?
Okay. Okay,
Yes.
sir.
Yes.
Good evening to all of you. Am I audible? Am I
Yes, sir.
audible?
Yes, sir. Yes, sir. Yes, sir.
Good evening to all of you. Greetings from Indian Concrete Institute, Mangaluru Center and QCrete Readymix India Private Limited. Today we have a webinar on artificial intelligence in civil engineering. I have a great pleasure to welcome you all to this webinar. Respected resource person, director and representatives from QCrete Readymix India Private Limited, all the members of ICI Mangaluru Center, invitees and participants. Today's resource person, Dr. Venkata Dilip Kumar P. is a faculty member at Mahendra University, a colleague controlling School of Engineering, Hyderabad. When we approached him, in spite of his busy schedule also, he has accepted our invitation and he has joined us. On behalf of all, I wholeheartedly welcome today's resource person, Dr. Venkata Dilip Kumar P. to this webinar. I welcome you, sir. And I extend my warm welcome to Mr. V.R. Kaushika, Director, QCrete Readymix Private Limited, and all the representatives of QCrete Readymix Private Limited. I welcome you, all of you, sir. And I extend my warm welcome to Professor Hemanta Prabhu, Secretary, Engineer Anil Baliga, Treasurer, and all the members of ICI Mangaluru Center. And I extend my warm welcome to invitees and participants. I welcome one and all. Thank you.
Thank you, Dr. Prakash, sir, Chairman of Mangalore Center. I'm Kaushik speaking on behalf of QCrete Readymix Concrete. I have today we are honored to have with us Dr. Venkat Dilip Kumar Pasupaleti. He is assistant professor in Mahendra University, UKL Central School of Engineering. Dr. Venkat Dilip Kumar Pasupaleti is a faculty member at Mahendra University, UKL Central School of Engineering. He did his master's and PhD from International Institute of Information Technology, Hyderabad, and he has published more than 100 research papers, and he has founded and started Center of Excellence, Center for Sustainable Infrastructure and Systems, CSIS, an interdisciplinary research center with the blend of civil engineering and computer science at Mahendra University, Hyderabad. He is currently working on structural health assessment and monitoring using wireless sensors for reinforced concrete structures, steel structures, and heritage structures, apart from retrofitting and rehabilitation. Dr. Venkata Dilip Kumar Pasupaleti, sir, has received Best Researcher Award in 2017 in Malaysia, and he has research collaboration with many universities, and he has traveled extensively to Germany, Portugal, Malaysia, South Korea, Japan to learn and also to teach and to collaborate with different lecturers, professors, faculties of different universities on different subjects, especially particularly related to the structural health monitoring. As I said, QCrete Readymix, we are privileged to have him today. And today, artificial intelligence is a buzzword among all the civil engineers, not only civil engineers, every faculty of engineering actually. So when everything is shifting towards computers, apps, and technologies related to computers, it is our responsibility to just tell what is happening in civil engineering field and what are the possibilities that can be explored and attached to such a happening field of artificial intelligence. And as I said, once again, we are thankful to you, sir, Dr. Pashupaliti Garu, for coming and honoring our request and trying to pass on the information which will be definitely useful for many civil engineering students as well as practicing civil engineers. Thank you, and we welcome you, sir. Thank you.
Yeah, thank you so much, Director Garu. Great evening to one and all. In fact, it is my pleasure to share whatever the knowledge we have been working on with you all. But first and foremost, I would like to thank ICI Mangalore Center for giving me this opportunity, and Mr. Kaushik Garu, the director of Readymix, Readymix India Private Limited. He has always encouraged me in this one. So special thanks to him. So coming back to the webinar, I am basically from a civil engineering background. Sorry. Even though I did my master's in computer science and structural engineering, just a second. Sorry. Yeah, I did my master's in computer-aided structural engineering, and that's how I was attracted to a little bit of computer science and into structural engineering. At that point of time, in the year 2005 to 2007, we have heard about artificial intelligence, but we were not truly trained into artificial intelligence. But then over a decade, 2015, 2016, we have seen a giant leap of artificial intelligence into each and every field. And I'm sure today we are all using AI in some way or the other. If you are into Facebook, or if you are just browsing your email, or if you're using Uber, Ola, anything, we use artificial intelligence in that. But then when we thought, how do we use this artificial into civil engineering? There are already many countries like Korea, Japan, US, Europe. There are a lot of other companies which are already into artificial intelligence. So when we went to Japan in 2017, things have changed, and that's where we started our journey in AI into civil engineering. So once again, welcome to this seminar and webinar, Artificial Intelligence in Civil Engineering. I would rather not provide much into technicalities of AI, but I'm sure if you have any such queries at the end of the session, for surely I'll put an eye into that. So especially thank my colleague, Professor Prafula Kalapatpu, who is from Computer Science Engineering, who has really helped me to acquire certain knowledge in convolution neural networks to do certain projects and structural health assessment and monitoring. With this, I would like to start my presentation. Just a second. I'm not able to. Okay. Okay, this is largely based on our experiences, and I have also taken some of the data from internet. So I should be specially thanked for the AI which is running behind the Google, which has helped me to get certain GIF images and videos, as well as certain matter to prepare this material. Outline of my presentation, I'll give a little bit background of artificial intelligence. Of course, that will not bore you much, and I'll talk to you about intelligence and little bit of machine learning and deep learning. And I'll also talk about artificial intelligence and certain tools. Of course, one of the basic food for AI is data. And we'll talk about general applications. And finally, we talk a lot about civil engineering applications. And since we are directly doing AI research at our research center, I'll also focus certain 4 or 5 areas where we are trying to incorporate AI in structural engineering largely. And finally, summary. Of course, it's very difficult to conclude any of this webinar because AI has just started in a country like India, especially into field of civil engineering, even though it is there in other fields. So it's just one line of summary, not a bunch of slides. Introduction to AI. When I was watching this movie, Alan Turing movie, I heard that in Second World War, this is the mission which has deciphered one of the messages which was sent by Nazis to bomb certain places. So Alan Turing was one of the person who actually invented this, made this, and he wanted to decipher the message. It says that because of this machine, more than 2.4 lakh people have been saved during World War II, and that's this is actually had deciphered the messages. In simple, this compromises of only two technical terms. One is called algorithm and second one is computation. I'm sure we all know the algorithm from where we start from start to stop. If my teacher says open a book page number 100, then what I do is I don't open from 1 2 3 4 5 6 7 8, but randomly I pick up some page, and then I'll see whether it is less than or greater than, and actually I'll do that multiple times to get the exact page. And that's what an algorithm is, binary search. We search here and there, greater or lesser, and finally reach the destination. Whereas computation is something which will quantify things. We're more interested in quantifying. In computer world, it is very much needed that we quantify things. That's how this AI has taken a giant leap into everything. Because civil engineering is all about numbers and we have to quantify. At the end of the day, when we're trying to talk about structure or material, or we're talking about any other kinds of loads or code books, anything, it's finally a number. So computation is that important. Alan Turing and said that I believe that at the end of the century, the use of words and general educated opinion will have altered so much that one will be able to speak of machines thinking without expecting to be contradicted. So already machines, there are a lot of machines in the field, in every field. Civil engineering has already have taken again a multiple steps ahead, building very bigger machines, and they started slowly becoming much smart and intelligent. He is also known as father of theoretical computer science and AI. History of AI, as said, I'll just give a glimpse of AI. Started all in the 1950, and in 1951, first time it was entered into chess game. I'm sure while you were all children, if you played a chess game with a computer 10 years back or basically 20 years back, every time you play, the computer would have been played the same steps. But today it is not true. You play, computer will understand your game, and every time you play, computer will change its play. That's what is AI is all about. It will learn. So in 1956, AI was coined at Dartmouth conference by John McCarthy. And 1959, MIT has started AI lab. 1960, we have a first robot, and that is also developed by General Motors. 1961, we have a first chat box. We have something called Eliza, where people could chat. It's not a voice, but it was a text chat bot. And then in 1997, IBM Deep Blue were the first one which won over Gary Kasparov, who was the old chess championship. So computers have taken a little over the human being intelligent in 1997. In 2005, or every year, we have DARPA contest where Stanford actually proposes this contest for all the students everywhere sorry, around the world, to have a vehicle which is started at the start and it has to reach the final destination without any kinds of obstacles. So all sensors and image processing will be taken care within that vehicle. And of course, we have something called IBM Watson. Even today, IBM Watson is very famous now. That has been installed in multiple hospitals where it can scan a human being and can tell what are the pre-alignments, where we have visited which hospital, how much it has costed, or what are the problems there. So much of data is there in IBM Watson. So you ask any question, it will answer. It's developed by IBM. In general, we all have questions. And what are the questions we have about AI? Is what is AI? Can machines outbeat humans in performance? Can this world become perfect? Can machines do all the work? How far are we today? What are the limitations? Are there any danger for humans? So even the research team still have this will AI serve or replace us? This is still a very big question to all of us as a scientist, still developing AI. But then but all the scientists are trying to implement certain guidelines so that machines will not overtake the humans and such. But we can never say anything about that right now. And then just before we say about AI, it is very much necessary that we see different kinds of revolutions which took over the generations or human beings. In 1784, we have the first steam power, and that's how a lot of work has been multiplied. It's the progress. It became much faster, and people were able to lift larger weights, move larger distances with the steam power. For example, the train. The second, in 1870, we have electricity. As long as the electricity is continuous, there was a mass production. I'm not sure if you would have seen this movie, which is a Charlie Chaplin. You can see everything is automized, and they wanted to maximize the production. So they had this even lunchtime have to be utilized for mass production. This was during 1850s and 70s. And in Industrial Revolution 3.0, which has happened in 1964, you have a lot of embedded systems, and we have information technology, and we had an automation where every hardware is automated. So 1964, we already are in era of hardware automation. So you can see this is a small GIF image, but it gives us a lot of information that how the hardware has been automated. And as nanotechnology is increasing, the size of all these electronic devices is becoming smaller and smaller, and still automation is becoming more precise day by day. And finally, today we are into a cyber physical systems. Today, I'm able to speak to you all because of an internet. You are all able to see these slides. This is all about internet. We have such with the great speeds of internet. This would have not been possible with 2G or 3G. Since the 4G and 5G, things will really change. Maybe in the next industrial revolution, 5.0 or even 4.5, I don't call 4.5, I can be physically presented as in a virtual reality or augmented reality form. That is for future. So this pandemic, even though it has disturbed a lot of human lives, but it has also opened a lot of eyes on technology and vast usage of technology into a different dimension completely. So right now, today, AI is able to change its own software. So softwares have become automated. This was not there before. So software automation is one big leap again. This is an industrial revolution. Intelligence. How do you call it intelligence? You just go type it in Google, and we all see that intelligence is all about a brain. So when we talk about a human, we'll talk about intelligence. He truly has a brain. That's what is always intelligence mean. But how do we define in dictionary? How is in simple? I'll tell only one statement which I took out from Google: the ability to acquire and apply knowledge and skills. So we acquire knowledge and we apply it. And then of course we do a lot of mind like we have a lot of other intelligences which I would not like to talk on this, but one is emotional intelligence, quotient intelligence, and all. We do play a lot of brain games. It can be anything. Sudoku is one of them, or getting up with puzzles, decipher, a lot of training we do with our brain. So the same definition in simple 3 words. According to the psychologist, intelligence means we have an ability to learn, and we have ability to recognize problem, and we solve that problem. These are the 3 different terms, but combinedly they are called intelligence. Ability to learn, recognize the problem, and ability to solve the problem, which means we are able to take the decision to solve the problem. This is what an intelligence means. Now, the 2 types of intelligence, one is natural intelligence and another one is artificial intelligence. By birth, humans are all born with natural intelligence. We are not given, but then we actually train to make ourselves a little quicker, but we're all born with intelligence. But when we talk about intelligence, especially when we talk about natural intelligence, it's not only humans who are intelligent, but there are other living things which are also very much intelligent. For example, if you see this one, Venus flight trap, I don't know how many you have seen, but there's a beautiful book which was written. on plants and their intelligence. This is one of small such kind of an example. You can see when a fly actually comes in, it just waits for some time and it catches, and it actually eats the fly. This is an intelligence. So because it's the action is going on, it's able to take the decision when fly is there, when fly is not there. And then this is a very sensitive, I'm sure, touch me not is a plant, very sensitive plant. And then when you actually touch, it loses, it comes together. Okay, so somewhere there is something the plant is actually thinking, that is, there is some touch and it's closing. Of course, I will not argue on any of these things because this is directly I've read in books, and I found it to be interesting and very logical that trees and plants are quite intelligent. We may not have understood, have did a lot of research, but yes, there are scientists who did a lot of research to prove plants are very much intelligent. This was one of the experiments. Humans had always had their friends, birds and animals. They always wanted these animals to help them in some kind of a work, and they wanted to test their intelligence as well. You can see a crow was given two sticks, one a smaller one, the longer one, which you're seeing in the video. But the crow actually picks up the bigger stick and actually eats, which actually says that crow actually is thinking, it's intelligent, it's taking decisions, it's doing things. And then similar to this, you can also see the crow is actually doing some small kind of a fishing here. And then there's one documentary which is there in YouTube which actually says that animals or birds which build their houses are built such natural friendly and so optimized in material and such great designs. They actually say that they are very intelligent kind of structures. They might not be smart, but they are very optimum and very sustainable kind of structures they have. And we have this one, a type of a parrot which has always been best friend of a human being, which can also talk. You can see how this is actually changing with the colors and playing with the colors, which actually says they actually think and able to find this is some kind of a pattern, color pattern. It is able to recognize and it can do the things. And then you can see a cat here, which is able to open the bottleneck, and it is able to take something for eat. And then similarly, there are a lot of examples on Google you can go and see. And when there is a cocoon which was actually locked and it was able to open the lock and came out. And these things do happen in our daily life. Also, we can see even this is not only in Google, but it is not only in YouTube, but we can see even in our daily lives. This is all about intelligence. And human being has been changed a lot in evolution. He has learned a lot, and one of the basic thing of human being which is not seen in any other living thing is communication. And I think that is what actually makes us to sit on the same platform to even share such kind of a knowledge, the communication between you and us. So that was one of the biggest weapon a human being always had. And if I see human being intelligence, let us put in 4 terms. We can observe things, we can understand, we adapt, and we prepare for the next. That's what is all about human intelligence, or intelligence is all about. Artificial intelligence, we want machines to act like us. We want machines to mimic like us. And if you have traveled any national or international, during even COVID, AI has actually played a vital role in checking the temperatures of human beings when they were actually traveling abroad. So every airport has a thermal signature machine, and they were actually using AI, and they were actually trying to they were trying to compare with certain known data and to know which person is at least attacked by COVID or little suffering from other kinds of parameters like fever and all. So we want something, a machine to do like a human being. That's all is all about artificial intelligence. So artificial intelligence, one of the big thing about artificial intelligence is data. Data is a very big thing. That's why I always write a big data. So as the data increases, every day, millions of people are taking photographs and uploading online, or the Facebook, Twitter, or in the WhatsApp, or whatever in social media or social platform. And there's a huge data every day has been increased, and it is kept at some server at certain geographical location. So somewhere around the world, it is kept somewhere. So data is very much important to AI. AI will be crippled if there is no data. For example, I took up in civil engineering because this is one of our live project which we were trying to do. So suppose you have two images. One image you can directly see, one image is a crack and second image is a spalling. And then there are two kinds of machine. One machine, you give an image to the machine to identify what is this in the image. And then that machine actually compares with the data which is already there with it. And then finally it gives the answer that this is a crack. But then if you give a different image, this image is not there in the data. This is not there in the data. So it gets confused. It doesn't give any output. This is digital image processing. So when you have image processing and all, it will actually compares with the only data which it has. But then we are not really interested into this. Machines are able to do this for a long time. Intelligent machine, when you give this image, what it does is it actually it doesn't, whatever the data it has got, crack and spalling, it takes all the features of that crack and it compares with this image and it gives that this is a crack image. So this is what is all about artificial intelligence or intelligent machine. So even though the data is not there in the data, it actually takes certain characteristics of this crack and compare with the new image, and then it gives us the answer. So the most important thing in this is the data, which is used as a training, and one is validation, and other thing is for the testing. The same thing. So how do you define artificial intelligence? The capacity given by humans to machines to memorize and learn from experience, to think, create, to speak, to judge and make decisions. And simple, we want machines to act just like a human beings. Beginning of artificial intelligence, I already said this is John McCarthy, who has coined artificial intelligence in 1956, and he defined AI as the science and engineering of making intelligent machines, as simple as that, which already there. The theory and development of computer systems able to perform tasks normally requiring human intelligence, such as visual perception, speech recognition, decision making, and translation between languages. Now, I'm sure if you are traveling to any of the state, you just have to take your cell phone, take an image of your unknown language. It will convert any language into any language you want. Conversion of language. It is also, if somebody is speaking in any other language like Bengali, it can convert to English, Hindi, Tamil, Malayalam, or Telugu, any other language. So that's already there now. The thought is all about AI. Intelligence. I'm sure you would have seen this movie, one of the famous movie, directed by director Shankar. And this movie actually is all about a human who would like to make a humanoid, which can learn, which can think, and can take decisions. That's what is all about speciality of a human. He can learn, he can think, and he can take decisions. So this is what the robo is all about. He make a humanoid, and it will also, but it is an artificial. It can also learn, think, and it can also take decisions. Of course, I'm not trying to talk on the negative aspects of this, but there are certain limitations and negative aspects, but largely focused on very positive aspects. And then there are people all around the world that are trying to make robots to do exactly like humans do, not only in thinking, but also in physical actions. So Boston Dynamics is one of the biggest research center in the world, which is trying to train robots into, they prepared a lot of robots. They make it spiders. They can actually clean a room. They made a dog which can sniff and run. They made a lot of robots there. So building artificial intelligence. So simple artificial with human intelligence gives an artificial intelligence. As simple as that. And then this is just for your information, like a machine playing chess. Right now, I'm sure in Hyderabad also we are using AI in traffic signaling, because we are able to take a lot of video from every traffic junction, and any vehicle which is passing the red light, we're just giving them fine of some number, and that's done by AI. Not completely is converted into AI, but sure in another couple of 4 or 5 years, everything will be converted into AI. So they won't need of any traffic police until and unless it's necessary. And third, I'm sure you all talk to Siri, and I think 5 years back, if you ask a question, it would have, if you ask question 5 times, it would have given same answer. If you ask the same question 5 times now, you could try. The 5th time it will tell, are you joking? So Siri has developed over the years, and now the number of calls you do, the number of mails you send, number of WhatsApp messages you send, everything is stored with Siri, and Siri knows more about you than yourself. Yes, building artificial intelligence is a very big area, which was even started in 1950s. As we said, it was in 1962 name came. But there are subset of artificial intelligence is machine learning. Machine learning actually it gives the skills to learn without explicit program. So it will train itself. You don't need to do the extra programming. It will train itself, and then it will give us the output. And then the subset of machine learning is a deep learning. And deep learning, as I said, it's a subset of machine learning, and it actually works like it has a lot of artificial neural networks. And the best thing about deep learning is it can actually improve itself. The code can improve itself. There are a lot of algorithms like artificial neural network, genetic algorithm, fuzzy logic, and colony optimization. There are a lot of things which I am not trying to talk about that right now. But a lot of these algorithms have helped AI in solving a lot of problems. So machine learning, again coming back. So I have these images, a lot of cracks, and then I said it needs data, and you can see the data here with crack and without crack. So you give this, we have used convolution neural networks to train the program. So it took all these images with crack and without crack, and then it studied all these images. And we gave the validation. It immediately said by 100%, these are the images which had crack, and these are the images which didn't have the crack. And then when we give the new set of images, immediately it has segregated or highlighted the images with red color of cracked and green color with non-cracked wall. Similar to this, we have did a lot of structural health assessment for various problems like corrosion, spalling, cracks, leaching, and water patches, everything. So we took all kinds of images. But the bigger thing is we need a lot of data to this. And this is, of course, this is published in AWS in Europe. Anyway, similar to this, I said this is a spalling. So we got a lot of data of spalling, and then we gave with spalling, without spalling, and there was a validation set. It was easily able to tell which one is spalled image, which one is not spalled image. We also have seen that there are images with certain kind of furniture, but then it was able to crystal clearly distinguish this is not the furniture, and able to distinguish between the spalling and non-spalling. And then this is the proposed architecture. I'm not getting into the architectural part. Yes. And then when we gave and when we run, these are the new images. It is crystal clearly being able to distinguish between the spalling and no spalling. You know, the day Uber and Ola have started, the day one, when somebody has used Uber or Ola, it would have given like 1 hour or 1 hour 15 minutes. And the car would have gone by 10 minutes or 15 minutes of difference. But today, if you actually use Ola and Uber, it almost gives by a accuracy of a minute to reach the destination. So the more number of data, the higher the data, the accuracy of these algorithms increases. That's why the data actually plays a very vital role. And this is also published one paper. And types of machine learning. I love this algorithms of machine learning because once you understand, they can do wonders for us. So machine learning is divided into 3 types of machine learning. One is supervised learning. Like if I'm a child, I know this is a father, this is mother, this is brother, this is sister. They tell parents or somebody teaches that they all are your family members. So I know them as a family members and start calling mother, dad, and this. So I'm supervised. So I am taught that he is your father, he is your mother, he is brother, sister. So that is supervised. In supervised, we do the classification or we do the regression. Okay, let's not get into the regression analysis or classification, but we all know the classification. So these are friends, these are family members, these are relatives. We have a lot of classification on this. And then we have unsupervised learning. When we see things for the first time, if nobody is teaching us, we don't know which tree it is. We don't know which animal it is, we don't know which bird it is, but we know it is a bird. We know still it is a tree. We know this is something different type of a food. We cannot name them, but we know that they are part of some kind of a family. That is unsupervised learning, and that we do a lot of clustering or dimensionality reduction. So clustering is that. So we don't know, but we can put them into a group. That is what is unsupervised. And finally, reinforcement learning. It's punishment or reward method. It's punishment and reward method. You do, you experience, and then you again improve. That's what is reinforcement. Reinforcement is you increase your strength. Every time you learn something, you reinforce yourself. Of course, this is what is supervised learning. So you are given different types of apples, pineapple, and banana. If you give an object, it will tell, predictive tool, it will tell that this is an apple. If that is not there in data, it will not give you anything, as I said before. Unsupervised learning, what it will do, it will cluster the things. So if you give 100 different types of sketch pens, same color, same pencils it will put aside, same pens it will put aside, rubbers it will put aside. So it will segregate and cluster them. That is what is called unsupervised learning. And finally, it is reinforcement learning. So reinforcement learning, I said, see, when I'm driving my car, I go and hit some curb. Car gets damages. So I know that if I drive the car and if I hit something, car will get damaged. So I'll see myself that I don't hit. If I hit, there is a damage. If I don't hit, there is no damage. So next time I'll not try to hit. In the same way, when child actually walks, clawing, when he walks, he falls down. He knows that he'll fall down. Next time he'll be careful. Then he'll see that he'll not fall down. He'll take and help of anything which is beside him, any objects, and then he'll walk. So that is reinforcement. It is basically nobody will teach. There is no clustering there. But then you learn yourself based because of the last result was either in favor of you or it is not in favor of you. That is called reinforcement learning. And today, so we know when we give an object, when we give an image, our algorithms will tell this is the cat. Now, when you tell localization, it will also give the boundary of the cat. And if there are different kinds of objects in the same image or different kinds of animals in the same image, it is crystal clearly able to distinguish between each. So for the cat, it did able to give the red color, dog blue color, and duck green color. So that is called object detection. And then we have neural networks which are used, and it will also do the segmentation of each object which has been detected. So this is deeper and deeper and deeper as we are trying to go deeper and deeper. So classification done will be simply in terms of image processing, but slowly we need machine learning and then deep learning to do inner and inner. And then supervised learning, I said one of the best example is biometric. Every day you use biometric either to switch on your mobile, or you might have been used in your offices. The biometric is one of the simple supervised learning, because my data is already there. There is no segregation of this. There is no clustering of biometric. There is, every person has got an inclusive biometric, so we use this. So the data is already there. Only for the data which is there we are able to tell. That's why it is called supervised learning. And second, face recognition. It's also supervised learning because our face is already fed online, and we give that this is face is related to this person. But then deep learning is used if the same face, if it is after 10 years, how it will be. We can use AI to tell how 10 years before, how 10 years after. That we need a lot of data to train that, because we need thousands of people who were there before 10 years, after 10 years. That data can help us in recognizing a person who, how he or she will look like after 10 years. Of course, that such kind of apps are there already. And of course, in India, now we are, people are doing a lot of projects in segregating and trying to understand whether it is a vehicle or it is a person or it is something, a digital sign, it is structure and all. We are able to segregate this image classification. In fact, trains drivers are about to have this such kind of an image which can immediately will tell within a 500 meters whether there is a person or animal which is crossing or sleeping on that one. So slowly things are getting implemented to avoid fatal accidents online. And then, of course, there are a lot of algorithms I just kept here only for your information: linear regression, random forest support, vector machine logistic, ANNs, and all. ANNs are mimic of human neural networks. It is human neurons. So you can see this image when you are seeing this is able to segregate different types of vehicles. So convolution neural network is used in this one. Anyway, so similar things are used for reinforcement learning and unsupervised learning. But let me not get into that because shortage of time. Like why so much of demand suddenly to AI? The demand is because today we have the higher computation power, and second, we have more and more data which is coming day by day. Either in terms it can be in hospitals or in general stores, or it can be a banking sector, or it can be any of these sectors. There's a lot of data which is coming in, pouring in, and because if you are able to understand this data, of course there are a lot of things which we can predict for future. And then better algorithms. I'm not sure the better algorithms in the world are always given by small children. That's why every year we have AI contest where children will come up with their algorithms to solve one problem. So the machine is always best than a human being because the machine has algorithms from the best of the best people. Obviously, it will be best than any human being on this earth. That is why we always have a doubt. And fourth, people are ready to invest because there are a lot of returns in AI. So these are the major four reasons why there is so much of demand in AI. And what contributes to AI? The first and foremost, as I said, it's department science, computer science. Second one, of course, philosophy is very important into this. And third, sociology. Fourth, mathematics, biology, neural science, and psychology. All these are there in the artificial intelligence. That's how slowly machines are about to generate certain kinds of emotions to certain situational. So that's what is all about a robo movie, which was directed in India. Now, programming languages, I'll not get into this, but just for you, we are using a lot of Python here. And of course, there are other languages like R, C++, Java, JavaScript, Haskell, Julia, and all. This is different programming languages. I can't get off layer, but we use a lot of Python for AI. Applications of artificial intelligence, of course, this I take from Tikvidan because I really like this application slide, because everywhere, wherever you are, whatever you are trying to do, you can apply AI, because that's where the human is trying to do. Whatever human is trying to do, there AI can be play a role. Like in healthcare, as I said, if any person who is visiting any hospital in India, immediately if his report is taken, and then machine will immediately tell that which hospital he has visited previously and what are the problems he had, when he was diagnosed previously, everything. And automobile, every time you go to a service shop, wherever you can give your vehicle anywhere in the service. It's just like healthcare of a human, it is just like a healthcare of automobile. Which part was replaced, which one was repaired, when was it revised, everything related to that. Automobiles are right now using AI. Of course, similar to that, finance, all the banking has AI. Surveillance cameras, now surveillance cameras can differentiate between animals, humans, and slowly they are trying to develop to understand the emotions of a human being, so that whether the person is sleeping or whether there is a theft which is going on, that we are able to get from surveillance cameras. Social media is the first and foremost to use AI, like YouTube. If you see Bahubali movie, it will guide you to another movie which is very similar to a Bahubali movie. It's based on that's unsupervised. So based on your taste, it will recommend such kind. If you listen to a sad song, it will recommend all sad songs. It's something like that. Entertainment, education right now is using a lot of AI. Space exploration, gaming is another very big area. Robotics, agriculture, e-commerce, these are the different applications which use AI, but I'm not trying to get into all this, but I'll definitely give some general before getting into civil engineering. Google, uh, I think 10 years back, if you delete the history, it never used to store anywhere. But today, if you browse anything and delete the history, it is not there in your system, but it is saved somewhere else. in Slovenia or in Germany or in another country or Africa, somewhere the server has got your data. And now, since we are talking about cloud, it is saved at least in 2 places, if I'm not wrong. And Google actually uses a predictive search engine. When you see here, when you are trying to type, it will try to suggest you something. If you try to type Vajpayee, it will give Vajpayee Prime Minister, something like that. So you type Narendra Modi, it will give Narendra Modi Prime Minister of India. It'll predict. So it'll base, this search is based on many people who have already searched. Accidentally today, when you do the search part, this search will change from the geological location, and it will also change from a system to system a little, because it will know whether the person who is searching is a child or an adult based on the previous search of the same system. That's why today you'll get an alert when your email is opened in a very new system. That's how the alerts are sent. So there's a AI which is working on it. And this is, I'll not get much into this, but you have to know JP Morgan's is one of the one which is using AI, like image recognition, because they have a lot of documents, 12,000 documents which have to be reviewed, and it would take thousands of human hours. So they are using AI to review all these documents and made it faster. And healthcare, IBM Watson uses, they are actually would like to have come up with a very single kind of an instrument where a person is just walking through that or scanned in that, and he'll be knowing everything about a human body. And IBM Watson is trying to develop. It has already given to most of the hospitals in US. So still this is under development, not a perfect machine yet. And Google AI can see through your eyes what doctors can't. So I'm sure you would have given your eye retina data while doing the Aadhaar card. One of the biggest data right now Indian government has about Indian citizens is about all the information about Aadhaar card. So it has got your address, father name, sibling name, mother name, everything, your address, phone number, weight, everything, date of birth and everything, eye retina, biometric, everything. So Aadhaar card is one thing which has got the highest data in India. It's a very big data. So AI with this, when it was actually trying to see, it has actually told that there is some problem with the eye, and it can actually tell about retina. So there was retinopathy is one such kind of an disease. If it is not known at the beginning stage, people can lose their eyes. This was able to set by Google AIs. Facebook, I'm sure you all know Facebook. If you just put your image, it will immediately recommend that he is so and so person, she is so and so person. So it is the first thing which uses deep learning to detect facial features and tag your friends. So now if my picture is posted by myself, if my picture is posted by somewhere in any other country, immediately it will tell. It doesn't matter whether the picture is in my Facebook or any others. As long as it is there online, somebody should have been tagged once, and then immediately it will give the information to anywhere. So this is actually, if you see any of your marriage CD, if marriage CD or birthday CD video, it can tell how many number of people have attended the function. In the same way, now these things are used in any hotels, motels, banks, retail stores, commercial complexes, so that they'll know how many number of people coming in, coming out. Previously, people used to count that. Now we don't have any such kind of a counting. Only surveillance camera is taking care of everything. Number of people came, it will also give the names who have visited and what is the approximate age of these people who have visited the commercial stores. So this is done by deep learning. And then finally, automatic cars. Tesla was one of the company, and Audi and Mercedes, they all have developed automatic cars which they can drive themselves. Reinforcement learning was utilized into this because it should not make an accident. Every time it makes certain mistake, it should learn from its mistake and it should correct itself. So that's actually used in auto cars. And you should know that 100%, I think almost Tesla is one of the company where 100% of the car is completely manufactured by machines. No more a human intervention is there. Similarly, into other companies like Chevrolet, you can see Chevrolet, so only machines are doing the complete manufacturing of these cars. Similarly, other companies as well. Hyundai is approximately 60 to 70%, and so on. For 1 minute, you have to excuse me because I would like to show some images which I've found where AI can be applied. So where can we improve, and how and where we would like to apply artificial intelligence? One thing, you apply artificial intelligence in civil engineering so that we actually move our society much faster. The second thing, we apply AI to the places where it's trying to bring down the economy of the country or making uncomfortable life for most of us. One of the biggest problem most of the countries are facing is a uh, traffic jam, and the jam increases if there is a flood or a rain. It's a havoc situation. So people with the Ola or Uber, they'll immediately know there is a traffic jam here, there's a rain here, and there is a lot. This is the amount of time which will take care if we take this route, and it will suggest the shortest path. And it is also called anyway. That's an ant algorithm. And then see, jam is not only India's problem; it's there elsewhere all around the world. So we are trying to apply AI in solving this AI traffic havoc problem. And then you can see this. Of course, this is all around the problem. And then floods. Floods. There is a speed of the flood, and there are a lot of GIS images and global positioning system, and we can know how many number of people are crawling in the water, how many kids are there, how many objects are floating in the water. Everything can be taken from a spatial image, and immediately we can come up with a solution. So and so place requires so much of food, so many of helicopters, so much of this. So these are the areas, because in Chennai there was a flood, and the last time floods in Chennai had actually has led to one of the biggest disappointment, because it was almost for like a week where people have not able to get the food. So now AI is working there. A little bit help of a drone, a lot of things have been changing. And plastic and sewage, water flow, all stagnant water. These are the places where AI, people are trying to implement AI, but how to solve is there are people who are keenly working on it, but it will take another 5 to 6 years where they can apply. This is different types of houses. We don't have, even though we have so many number of houses in any place, if we want to tell from a drone image how many are RCC structures, how many are mud structures, how many are these things, if the image is taken from a 360 degrees, then immediately we can get the housing density of any area. Based on that, we can actually plan the disaster management. So these are the places where AI will play a very vital role in solving from the perspective of civil engineering. But let's see few. Now, a lot of revolution has been taking place in civil engineering because of the technology. So the lot of biggest revolution is going to take place in next 10 years. A lot of things will change because not many of the people would like to work on the field. So they would like to replace all the human beings with the machines, and machines are going to work all 24/7 with a lot of accuracy, robustness, without any kind of mistakes. So technology is going to take a big leap in that. So there is no field actually to sell in civil engineering. There is AI cannot be utilized. AI can be utilized in structural engineering, transportation, geotechnical, environmental, irrigation, surveying, construction, earthquake. You tell any field there, AI can be used. For example, this is Microsoft HoloLens. So a couple of students, my students, our students are working in Korea on using HoloLens to understand the building before it actually built. In fact, in last 3 or 4 years, even today, you might have seen a lot of walkthroughs actually created by 3D Max by architects or civil engineers to see exactly how your house looks like just before it is being constructed, so that if there is any kind of a change required, that can be implemented in the structure ready-madely. So with the help of HoloLens, we can do this. You can see this. The advancement has gone such far. It's not only a building. You can actually also see the greater society, or also you can also see the urban planning. You can see the distribution of the houses, how they are distributed, and you can see all the dimensions. You can see the widths of roads. You can see a lot of things with the Google HoloLens. Now, in next few years, 5 to 7 years, there are a lot of people who would use this augmented or virtual reality in structural engineering. In fact, I don't have another slide where I have seen people are using convolution and artificial neural networks in calculating the material strength. Before that, it was just a laboratory experiment, but today using neural networks, we can actually find the strength of material without doing any test in the laboratory. And this is one, this is second. When you keep your HoloLens to yourself, you can actually feel how your room will look like with different kinds of layers. You want your house to be with a greener, you want your house with a wooden flooring, you would like to have a tiles, you could like to see any kind of a layers. So with all kinds of layers, how will it look like? Of course, things can change in engineering. And then see, I am not there at your place, you're not at my place, but we all would like to discuss on one point, and then we would like to project something in front of us. So you can see 4 people are standing there who are physically present, and 2 people are not there and they are virtually present, but still the discussion is going on. So anywhere in the world, any problem about the structure, you don't really need to travel there. Now, if that is being taken 360-degree image, we can build an augmented virtual reality of that structure. We can look, we can expand, we can zoom in, we can go exactly that and see that and solve that problem. So slowly this leap is gonna take care a lot of problems, and person anywhere in the world can solve any kind of a problem, if at all, if we are capable of. And that's where the building information comes in. BIM was 3D, I think 7 years back, but BIM had XYZ, and it also had time schedule in it, that is called 4-dimensional. When it had a 4-dimension, it has also got timeline. 5th dimension, we also have a material and how far that must have constructed everything, that is also done 5D. Now Singapore uses 5D BIM. And it also, BIM is not only structural engineering, it consists of architectural, it consists of electrical, it consists of plumbing. All kinds of fields are integrated into one simple software or one simple surface, that's called building information model. And it has been changing a lot of things in the market right now. I see from this university, if I call any civil engineering company, the first thing they ask is, do your students know BIM? If any of the company like L&T, Raheja, Shapurji Paulanchi, the other companies like Adani, when they come to campus placement, they would like to take students into construction management who know this BIM. And then this is another thing where you have a plan and you can actually see the building, and also you can rotate it. In fact, you can also see the interiors of that. Even though this image, actually I took it from the internet, but we have also did such kind of an experiment with other project, which I will go into show soon. And then this is another augmented reality. If you see in the right side, this is virtual real mode, you can see the structural work, you can see the architectural work, you can see the mechanical, electrical, plumbing, curtains, landscaping, everything. So you have a different layers which are there, and you can see each layer. And every time somebody is updating in the construction site, you will know how much your building has actually updated, and everyone has to update it. And if some person is not updating, he just have to take an image of that. That's it. A software will adapt itself and improve and update its model. That so much of construction has actually taken place at the site. So you can see how far this thing is changing. And this is another thing. If this is the BIM you have in your hand, and again I'm saying, which is actually the interiors are taking place. And then when you actually combine your background image with the BIM, you can actually combine merge both the layers, and it will immediately tell if something is missing at the site which has to be implemented at the site interiors. It'll immediately tell, okay, plug is missing there, wire is missing there, plumbing is missing there, glass is missing, door is missing, anything. So the construction world surely will not depend more on expertise of a person, but it depends on the cell phone or the tab, or you have an equipment which will help you to understand the site. Now every company has got this problem. Whenever any experienced person leave the company, it will be very difficult for juniors to carry on the work. But here, since the equipment is taking care, there won't be any such kind of a problems. But again, I'm saying, I don't know whether this is a limitation or an advantage of the system. Been visited Burj Khalifa once, and I know I was not able to get the 3D of that because of certain restrictions of that one. But Burj Khalifa is one of such kind of a structure in the world which is installed almost like 180 kinds of sensors from the bottom to the top, including the foundation. They actually measure the temperature, they actually measure the deflection, wind, earthquake, and all kinds of things are measured 24/7, and everything is recorded. Now the data is that big. Human being cannot have an eye on that sensor. So having 180 different types of sensor and everything you would like to work, that's the biggest challenge. It will take days of time. So now they have using machine learning in that to segregate data and to give the alarming. If there is anything such thing like that, we immediately get the alarm. So Burj Khalifa is one structure which is powered by AI. Even tsunamis or earthquakes are also using such kind of a knowledge where immediately we get the warning because simulations are being carried at one powerful system. Of course, this already know you can switch on, switch off all kinds of equipments in your house. These are all called smartphones, and basic UG kids or even school kids are able to write their own code to switch on the fan, switch off the light, switch on the AC, switch on everything. So these things, a simple Raspberry Pi in your house connected to small sensors in this can help you in converting your home into smart structures. Now people are even constructing the embedded sensors in the structures to know the structural health. This is modular construction. In fact, here this is modular construction, but then complete modular construction will be done by robots in future. Precast, prefabricated structures will be built by robots. Once they are designed and programmed, robots can take care of such kind of constructions. And this is another thing which is very much into highlights in all the nations is 3D printing of the houses. People are able to print with mud, people are able to print with cement, but they are able to try to build these houses. So here you can see the human intervention is there, but slowly people are trying to come out to minimize the human intervention in building 3D. So this is another big area where AI is playing big role into 3D printing of the structures. So these are all structures with the bottom which you see are already printed with a 3D printer. So the bottom right side, third one, which you are seeing the one, people are planning to build eco-friendly houses in continuous rows. So this is again in the future. This I would not like to touch, but I will definitely would like to tell that there are architects are replaced by certain kind of a programming where program will share its knowledge with an architect to design in such a way that it is very much nature friendly. And all these structures are called biomimic, because somewhere the geometry is in favor of nature, or it is actually taken from some kind of an insect of a plant or a tree. So biomimic structures are trying to become eco-friendly, sustainable structures are designed by AI, not by a human being. Of course, these are some images. And somebody who truly interested in such kind, so there are certain 2 or 3 books which are written, architecture and nature. We are trying to imbibe an architecture from nature and incorporate in structures. Since there are lots of architectures for smallest plants to smallest organisms to plants, birds, and anything, we would like to see that architecture can be kept to the structure or not. So such combination is tested by AI. Anyway, so biomimic structures, you can see the biomimic structures. I'm sure at your houses now we also have indoor farming. Indoor farming, you can see a lot of retail stores where indoor farming is happening. Okay, self-healing concrete, as I said, this everyone knows about self-healing concrete. A lot of bacteria which is induced in the concrete, and then that can actually produce a lime and can heal the concrete, can close the cracks. But I'm not trying to talk about self-healing concrete, but I'm trying to talk about an AI, which is trying to study the probabilities of different mixes of concrete and different mixes of different kinds of bacteria and weather conditions which can heal the concrete. So a lot of programs are being done, and then this is actually discussed every 2 years once in one of the biggest conference on concrete. Of course, this you already know, I'm not getting into this. This is something called, in health monitoring, fiber optic sensors are gonna take a big role. Like for traffic and for monitoring of all the structures, there is a huge data. This is called FBGs, fiber bragg rating, which is induced into the fiber optic sensors. And every time there is a vehicle which actually passes through, we'll get the number of vehicles, weight of the vehicle, fast of the vehicle, and so much of information about the vehicle which was not possible till today. So all kinds of equipments which are dealing with for testing or calculating all this will be replaced slowly by with this advanced instruments, which will change the complete view on the civil engineering field. So it is in transportation engineering, as I said, easily AI algorithms are able to distinguish. It can able to calculate number of vehicles, and based on that, traffic lights will change its time. Right now we have a traffic light, we 60 seconds, 120 seconds, 180 seconds everywhere, but we want somewhere something have to be the traffic light have to adapt itself to the based on the traffic, not based on time. So this is being implemented at certain places, even in India as well. This is from the Google. Smart autonomous vehicles, they have to be tested. So this is actually the left side corner in the Google source is the actual one, and the right side is actually the prototype modified in a vector format. It's called vector format. And then we'll actually see how to automate the vehicles, because this vehicle should be able to crystal clearly distinguish this is a barrier, this is the lane, these are the other vehicles with which we should are not supposed to hit or get in contact with, and they should also maintain certain kind of distance so that the sudden braking is possible before actually any impact. This is another very big field. Actually, a lot of neural networks are being used in understanding the soil properties. Even they are able to know the pile capacity. Right now, we used a hammer test to know the pile capacity, but neural networks are kindly replacing the actual in situ test to replacing in situ test to know the pile capacity. And we are able to know the settlement of the foundation. And these neural networks are also used for liquefaction slope stability. So there's a lot of AI which is used in geotechnical engineering as well. IIT, few of the IITs are using image processing, especially if there is a water. They actually have sensors in the slopes, and they're able to tell whether the slope will fail or not within a couple of hours. So there they're using machine learning there. Environmental engineering is another field where a lot of AI been used. I'll tell one simple field. Right now drones are used and indoor farming is used, and indoor farming is fully taken care by the machines. So they actually pour the amount of water required, and they also see if there is some kind of insects or anything, they'll pick up, they remove, they pour water. Everything is done indoor. And the person you see with a tab, he will immediately know what is the percentage of the plants which are really good, and if there are something called pests or anything, they'll immediately know from this one. And actually even drones are used to take every snapshot of each one, and with this we can tell the quality of the farm which is going to come. And based on that images, it will cut into grids and immediately know whether we have to use water or pesticides, anything that will immediately know. Construction management is the one which will be affected soon, and this technology will be implemented in next couple of years into whole of construction management. You can see the drone. If you see clearly here, it is able to distinguish how many number of cars are there, how many number of trailers are there, or there are different kinds of objects. It's able to cluster different types of objects. Based on that, we can tell that this construction site has so many vehicles related to this, so many vehicles related to this, so many people related to this, or what is the area, how many buildings are there, everything. And this is an image which is taken by the drone. This is to inspect how many people are working on the top of the building and how the things are being moved from the bottom to the top. And same thing, if you see, this is another thing, a little advanced, even object identification we call it as. So based on the cap color, it will tell how many number of engineers are there, how many number of site engineers are there, how many professional engineers are there, how many workers are there. Based on colors and all, it can immediately segregate and can tell. So you can see here it is telling that concrete finisher, it is able to tell it is a carpenter. You can see here. So there are different types of people who are working at the site. So drone and AI at construction site, so you don't, person need not go on top of the structure how many number of people are working and what are they. So immediately with this, immediately we can tell quantify things. That's how I started my first presentation, quantifying things. And then the big structures, the tall structures like wind turbines have been one of the most challenging for the maintenance. Person have to go internally in a lift or staircase to top of the structure, and they have to know the identification of any kind of a damage. Now the drones or robots which can go take higher resolution of images and can immediately know if there is any maintenance problem with the turbines. And this is another thing. This is very recent one. We also got a very recent project from offshore pipelines. So he has a camera. He has kept this specs, and immediately he will know what are the kinds of defects which are there in the pipe, whether it's a joint or it is at the line. It is anywhere. So immediately we will know the defects in the pipeline. And this is what is another kind where you just take a snapshot, a thermal image, immediately you'll know. So you can see this is a part of BIM as well. You can see design review, BIM coordinator, class detection, install validation, progress tracking, change order, punch list, collaboration. There are a lot of things which you can actually see with a simple snapshot of your app. There are a lot of things which are being done. Now I'll tell in 5 minutes what are we trying to do at our research center, AI research center. I'm not trying to include all, but basic few which we have got few results. We are trying to build a digi encyclopedia of Indian traditional houses using augmented reality. We have Krishna Chaitanya, Prafulla, and me who are working on this. To start this, what we did was we had an Indian national challenge. We called people from different parts of India to come up with a prototype house, and we wanted to tell them what is the science and engineering behind that structure. And when they brought and showcased here, we already said them that we are going to digitize this structure into a world where you have to keep a HoloLens and you can walk into that building. So Niket was one such kind of an event which took place at Mahindra University, and you can see the left topmost images are real and right side images are all developed in using augmented reality. Now you can project anywhere and you can actually walk into this house. And background wise, we have not yet synchronized, but we wanted to tell that this house is built in Himachal Pradesh. This house is built with stone, wood. It consists of a sloped roof, and this is house can have an age of 100 years or 150 years. This is resistant to earthquake, and it will also talk about the lightning part, wind part, and it will also tell about different kinds of materials as well. So we wanted this digi encyclopedia to talk to you and tell what are the materials it has been used, when it was built, when it was developed in that place, Himachal Pradesh or any village, and it will give the scientific reasons behind the materials used. This is one of our the major project which we are doing at our research center. And this is one of the old structure in Himachal Pradesh, Tatar House. Actually, this is a masonry building. This is there from 450 years old. This can resist even 7.5 to 8 magnitude earthquake or 0.32 G ground motion. So this is still there. So we wanted that knowledge to be sustained, because it is not that we are against of concrete but in favor of concrete, but we would like to have this all knowledge stored at one place. That's one of the reasons why we are building this digi encyclopedia. And then this is cloud architecture. This is one of the live monitoring of the bridge we are trying to do now. We are using only accelerometers, and this is the testing of the bridge with the railways. And then we build our own web, which uses a lot of sensors data, and that sensor data is monitored by a background program with limitations and alerts. So immediately, if anything crosses certain permissible limit, immediately all the people who are involved in this project will get an alert message. This web is developed by two current third-year students, Vishwesh and Surendranath, and supported by our PhD student Sairam, who is in civil engineer. So we have a civil engineering and computer science students who are working together in developing this IoT, Internet of Things. And okay, sorry, okay. This is another area where we are trying to contribute in a very big way, is a heritage structure. This is 1000-pillar temple. Of course, you just take an image with your camera, and then we are trying to take all the dimensions, everything, 3 dimensions from the image, and we are trying to build the structure only from the image. And you can see there are different structural elements which have been taken image. From that we did develop this 3-dimensional, and we did analysis. Finally, we would like to know the structural stability from the model which is developed from the images. And this is another one, understanding the foundation of historical structures. Music is one thing, echo is one thing. So there's a traditional knowledge on the sounds for civil engineers which has been taught some 200 years, or sorry, some 1200 years back, which we are not taught. Now civil engineers don't understand the engineering, sound engineering. But in olden days, in ancient engineering, there was sound engineering which was used to cut rocks. I don't know how many of you are aware of that, but that was used to have a very precise carvings, sound and water, not the only metal part. So we were trying to understand how that has been contributed to the heritage structure, and we were trying to understand that. And for that, we did certain vibration tests. Still, this is under progress. And this is, of course, I said this is another bridge which we tested in Japan. Me and another team from Korea and UK, Norway. So we tested one of the bridge. When we test the bridge, when we wanted to excite the bridge, we hit with a hammer so that we actually get the vibrations. Or human jumping is done on the bridge to get the bridge parameters. Basically, we do the modal analysis and immediately we'll tell the health of the structure. I'm not getting deeper into this, but if you have anything, of course, I'll add. This is a FEM model, and these are the results which we compare with the FEM result and with the experimental result. One which is existing at the site and one which we actually designed. We know how much it has been deteriorated and where it has been deteriorated. Okay, this very recently we tested in our lab. We took the video of a concrete cube which has been tested. And what is that we wanted to tell is at what time the crack has started and how the crack has been propagated and how the cracks are there. Of course, this all depends on the orientation of coarse aggregate in the concrete sample, but we wanted to know because there are a lot of surveillance cameras and they'll be taking videos around the world. If there is any structure which is developing in a small symptom like crack or patching or spalling, immediately if you would like to know, we need to train this algorithm. So again, here also we used image processing and CNNs. And this is how in each second you can see the how our algorithm has segregated into video is segregated into number of image, and each image is processed to know the crack, and after that we have also tried to know the propagation of the crack. So we gave the crack length. This is another thing which was used, image processing, to calculate. You just take a cell phone, take the image of any crack, immediately we would like to know the length of the crack and width of the crack, and if you would like to know, it will also recommend crack type, but I'm not sure. It will not be able to tell whether it is a structural, non-structural, but otherwise crack length and crack width are okay. With this, of course, I have taken too much long time. I would not like to bore you all. This is where I would like to stop. But largely, I've concentrated on applications of AI into civil engineering. But I didn't touch much of into deep learning. But I would like to tell one single statement that AI is all about imitating machines, imitating like a human beings. And deep learning is always, it's all about mimicking the human brain. So that's why we call it neural networks. So we develop a neural network. Human beings have a lot of neurons, very similar to that human. We developed a neural networks for a deep learning, whereas machine learning is an algorithm which is trained with the past data. Anyway, so by this, I would like to conclude here. I would not like to take more, but definitely, surely, I would like to thank again, once again, ISA chapter Mangaluru and QCrete organization for giving me this opportunity to share fundamental knowledge and AI into civil engineering. The last thing I would like to say, it depends on us whether we would like to be work in cooperation with the machines. Then of course it's going to play a vital role in civil engineering for everything: management, planning, analysis, traffic analysis, everything. But then if you are trying to stand opposite to machines, then it will be in a Terminator movie. So they're going to terminate. So there are a lot of limitations to this as well. So AI is going to take a very big leaps in decade. A lot of things it's going to change, but we have to be, at the same point of time, we have to be very careful on how we are trying to develop algorithms and in which direction. Things developed in the direction of defense, that's one big area which is truly challenging today, because the machines can be turned into anyone at any point of time. That's a small summary. Again, acknowledgement, I always give acknowledgement. Without my team, I would not have presented this, which we are all trying to develop this. So there are some companies which have given an opportunity to use AI in the real field, especially KDM, NVLN, Varshita, and Vasma. They've been giving a lot of data to us. There are certain projects which have not been presented because of the time schedule, but otherwise I would have been happy to present more. Special thanks to them as well. So the whole inspiration of artificial intelligence in our research center is for the Professor Profula. Once again, she contributed a lot in this field, and that's how we took up that into the civil engineering field. Oh, thanks once again. If you have any queries, I'll take a couple of questions. Otherwise, yes, thanks again for your patience listening. Hope I have not bored you. Hope I have given small idea on opening AI into civil engineering field. Open to the floor. Thank you all once again. Thank you very much.
Some of the questions, Anjali madam, can you take some questions? Can you read out some questions? Maybe 3 or 4 or?
Yes, sir. Sure, sir.
Yes.
So the first question is, how can we use AI to detect and quantify corrosion in RCC members?
Yeah, first thing is when we are trying to segregate, we need a lot of data of images which are based on the corrosion. So immediately that image will be segregated whether this image has got corrosion or not. It won't give the quantification of corrosion. Since we know every image is actually divided into number of pixels, then we do the image analysis. Then when we do the digital image process, we'll get the number of pixels which are with that color, and then we will be able to tell what is the quantification of corrosion in that image. That's how we were able to quantify the crack length and width of the crack. So two parallel process. Step one is to segregate the images with corrosion and without corrosion, and the ones with corrosion will actually move forward and then quantify things based on the number of pixels.
Okay, so the next question is, how AI is used in slope stability?
Very recently, IIM Mandi, see, like a slope failure is based on cohesion and internal friction. So there are certain sensors which are embedded in the slope soil at every few distances, and they are able to know the vibrations, and they are integrating the small vibrational data movement at different depths, and they are able to calculate and simulate numerical solution, and then they are able to tell whether the slope will fail or not. This is a live project which is actually taken care by IIT Mandi. But if you are interested a little bit more about slope failures and slope stability using AI, you can always read a couple of papers which are already there on the site. But you need to understand that whenever we are trying to give the input data for slope stability, apart from the material and slope, we are also trying to give the vibration data, and then they are integrated, and then we are trying to find. So that's one of the way. Of course, there are other approaches as well, where people are trying to use drone images to find the slopes, and continuous image they are trying to find if there is any change in slope, and immediately they are warning that there might be slope failure. That's a continuous image processing data, but it will take a lot of time. Instead, you put sensors at different places and then take the data of vibration. That will be much easier. You can read that paper. Okay.
Okay, so the next question is, thank you, sir. So the next question is, what are the skills needed for a civil engineering graduate to be a part of AI? Is there any online course for civil engineering AI?
Right now, like IIT Bombay, there are a couple of IITs, and there are online courses on AI. I wish you could actually take certain courses on AI, especially using Python. What it will do is it will give you small assignments to implement AI at your place. Like for us, the first experiment what our students did was make our room smart. So they bought Arduino, Raspberry Pi, they bought certain piezo sensors, and they wanted to make switch on, switch off. They would like to know whether our tank is with full of water or not. So small projects. So this course of 2 months or 3 months, which will help you in doing small experiments at your home. So there is no specifically that I have not seen that you are trained AI into civil engineering. No, right now I have not seen. But you can use AI algorithms online. There are a lot of AI algorithms online. If you upload a video, it will segregate a lot of things. Like if you take a video at construction site, if you take a video of a railway line, it will immediately help you in segregating things. It will tell this is the railway line, this is the blast, this is a person, this is a buffalo, and all. Freely available are there. But before going to that, if you take 1-2 months course on AI with programming, especially it is called machine learning with programming, I think that will be, it will open a lot of horizons to you. But yes, it's easy once you get into that. It's not a difficult task at all. Yes.
Thank you, sir. The next question, does AI increase cost of construction without dwelling on the quality benefit?
Actually, I didn't say one small statement. UK predicts that there will be more than crores of people who will be losing job because of AI. Because lot of project management, you don't need to go to the site. So a lot of traveling, lot of logistics, food, everything can be reduced. So implementation of AI currently, if it is AI is charging something, so apart from that, definitely definitely there will be reduction in the cost of construction project. But there have to be a lot of projects which have to use AI. But the first time at the beginning, it will cost, because we are trying to bring the technology. Maybe in terms of drones, it will cost. Maybe in terms of software, it will cost. Maybe for the people who are doing live monitoring, they'll cost. Because one worker is given 1,500 rupees or 2,000 rupees at the max. But the engineer who is doing live monitoring of this site is charging more than 1 lakh. So there is also compensating right now. So right now, I don't tell anything about the cost because getting AI and implementing at the site is little costlier right now. But if there are many people who are implementing, definitely the cost will reduce by multiple folds. This is one side of an angle. Second side is AI will remove jobs is one thing, and second thing is there are a lot of other opportunities of AI. So there are also opening of a lot of AI jobs even in construction job market as well. So I don't think many people will lose job, but people who have been outdated in these skills might have this kind of a challenge of losing job. But as we also have new jobs as well. So construction cost will increase at the beginning, but it will go down drastically when a lot of AI is implemented at the site. Okay, that's based on my experience. It might change a little.
Thank you, sir. The next question is how AI can be used for water resources engineering. Can you provide an example?
Right now, most of the water projects or water linking projects are surveyed by human beings. So a lot of these things are surveyed like GIS. GIS is one thing where we used to take a lot of Landsat data images where it can segregate, it can tell us this is the land, this is the water, this is the trees and all. So continuous images of these data is now read by AI, and it is suggesting that this is depletion by so much of percentage, so much of ground is losing its water and all. So there have to be multiple people who should understand the data, but AI is giving the answers quickly, and we are able to act quickly and then able to save. So there's a lot of field, even though I did not do much of research, but I know that AI is being used in GIS in understanding the groundwater storage and increasing the groundwater level. I think slowly we'll also see in the newspapers. In fact, it was also there in today's Times of India newspaper, the role of AI into water conservation. Okay, I don't know exactly I have given your answer, but yes, GIS images are using AI to understand the water in the country.
Okay, thank you, sir. Sir, that's all.
Thank you. Yeah, thank you so much once again, especially QCrete, Kaushik Garu, for giving me this opportunity to share our knowledge. But I have seen that it is kept as a very fundamental so that people don't get bored. But I am, again, I'm saying our journey in AI has just begun and we are not the experts. We are trying to utilize AI in giving certain problems to the society. So if you have anything, you can always contact technical and you can write your questions to technical@qcreteindia.com. And if there are certain questions, I will definitely surely answer those things. Once again, thank you all the participants for your patience listening, and hope you have given. I hope you have taken certain points. And special thanks to ICI Mangaluru chapter for giving me this opportunity. Thank you so much, and for Better India. Thank you.
On behalf of QCrete Readymix Private Limited, we are extremely thankful to Dr. Dilip Garu for this extraordinary lecture. It is really mind-blowing. You have opened up many possibilities for civil engineering students and civil engineering practicing people who are in the field actually. What it says is that ultimately young engineers who are good in computers and software and artificial intelligence, eventually they will reap a lot of benefits, and others who don't follow probably, sorry to say, they have to retire sooner or later, because if they're not in step with the technologies which are happening. And I remember there is a beautiful statement by Dr. C.K. Prahalad, who is a management guru, who says, speed is God, time is devil. If you don't pick up these changes which are happening in the civil engineering field, people will be lost. It means we will be lost actually. And with this, I thank Dr. Dilip sir for giving this wonderful lecture. And I thank our MD, Shelly Fernandez, Mr. Shelly Fernandez, for giving us this opportunity to host this webinar. Also to Mangalore Concrete Institute, Indian Concrete Institute Mangalore chapter for hosting this. And especially we are thankful to Dr. Prakash sir and Mr. Anil Baliga sir for this opportunity. And I also thank all the participants who have come on this Saturday to listen to us actually for this wonderful and exciting lecture from Dr. Dilip Garu. Anil Baliga sir, you want to say one or two statements, please? Anil Baliga sir.
Yeah, thank you, sir. I think I'm not here to make any statement. I am just surprised that we are much behind the present things what are happening, and totally impressed by the presentation and the knowledge what you have gained, and excellent way of letting all of us know that what is the future of civil engineering as a whole. So wonderful session. I think we have to get one more round of special talks on similar topic from Dilip sir. Whenever you are free, on maybe part 2 or part 3.
Thank you. It will always be a honor. Thank you so much.
Wonderful sir. Thank you so much, sir.
Thank you.
Thank you, Dilip Garu, once again. And we will sign off with this, and then we'll bring a similar topic hopefully next week. Thanks a lot to all the participants and the office bearers of Mangalore Concrete Institute Center. Thank you very much once again, Anil Baliga sir and Prakash sir and Dr. Hemant Prabhu. Thank you. Namaste.
Thank you.